Welcome, Hornets. In this video, we're going to be talking about particle motion and doing a review of what we covered in class. So we are talking about a graph of a velocity. Now, what is important to remember is that unless the graph is defined as having the endpoints being included, they are open circles, as we cannot differentiate at an endpoint on an interval. So just please be aware of that as we go forward. Alrighty, so let's go ahead and begin. Now, there's lots that we know about these graphs. For example, we already know that up at the top, the slope is 0. It is a critical value, or a value where the derivative is equal to 0. And we know that our object is at rest when velocity is equal to 0. So if the object is at rest, it is reaching a maximum velocity, then we are looking at a maximum velocity here. And this is what we would then call a minimum velocity. Now, as we're looking at this, we're going to just start talking about convention. Now, by convention, whenever you have a velocity that is greater than 0, that means above the x-axis, a particle has movement to the right. So we consider it a positive movement, moving to the right. This is obviously moving along a horizontal or x plane. That would then imply that when we have our velocity, v of t, less than 0, we have movement left. So that's the first thing that you need to remember, is that when velocity is positive, a particle is moving to the right, and when velocity is negative, a particle is moving to the left. When the particle is not moving, is happening at the velocity equaling 0, we say that the object is at rest. Now, a couple of things are happening here. For example, on this increasing interval, so this is increasing velocity, we know that our acceleration is positive. So when we have an increasing function, the first derivative is positive. So if we have an increasing velocity, the next derivative must be positive, and therefore we are talking about an acceleration being positive. Then we have a decreasing velocity, and applying the same principles, that would imply that the acceleration is negative, and that would include all the way down to here, and therefore acceleration is still negative. And over here, acceleration is now positive. Now, if we convert to speed, okay, speed is the next thing to consider, and speed is the absolute value of velocity, which means it's a direction and a rate. So a rate of change, also known as a magnitude, and a direction. Now, this is a way in which we describe vectors, so we're now kind of talking about a vector here. And it works like this. If I know that my particle is at rest here and at rest here, then I have to be moving to my maximum speed right. So our maximum velocity is really our maximum speed right. But our minimum velocity, converting it into speed, would now have to be a maximum speed left. This is now a maximum speed left. So that means that speed is increasing here and decreasing here to our rest position at B. And then as we move along our x-axis towards C, our maximum speed to the left, we once again have an increasing speed. So we're looking at a situation where speed is increasing when acceleration and velocity have the same signs, but speed is decreasing when velocity and acceleration have opposite signs. And so that's something that we're going to have to write down. Speed is increasing when acceleration a of t and v of t, velocity, have the same sign. And vice versa, speed is decreasing when acceleration and velocity have opposite signs. So we've got quite a bit here. Let's just make sure you see that. We have an object is moving right when velocity is positive. An object is moving left when velocity is negative. An object is at rest when velocity equals 0. Acceleration is positive when velocity is increasing. Acceleration is negative when velocity is decreasing. Speed is increasing when velocity and acceleration have the same sign. And speed is decreasing when velocity and acceleration have opposite signs. I'm at my maximum speed to the right when I am at a relative maximum, and I am at my maximum speed left when I am at my relative minimum. Well, we also have our maximum acceleration. Maximum accelerations occur at points of inflection. Points of inflection are at a change in concavity. From concave up makes a cup to concave down makes a frown, or vice versa, working from a concave down to a concave up. These are what are referred to as points of inflection. Concavity is an aspect of acceleration. When acceleration is positive, a curve has a concavity that is concave up. When a second derivative or acceleration is negative, the primary curve or the original function is now concave down. So we're talking about our second derivative for concavity and our first derivative for the aspect of increasing nature or decreasing nature. Please remember that at points of inflection, acceleration is at its maximum decrease or maximum increase. Now, the last thing about particle motion that we have to kind of work with is this idea of position and direction. So position are s of t or x of t, and that has to be in relation to our origin. So I have either s of t positive or I have s of t negative. And then we have direction. Well, if I have a positive position and I am moving to the right with a positive velocity, then I am obviously moving away from the origin. Yet, if I have a negative velocity with that same positive position, I'm obviously going to be moving towards the origin. Well, the same is true when I'm looking at a position that starts off negative. When I have a negative velocity with that negative position, I am moving away. And when I have that positive velocity with that negative position, I'm moving towards. So we're going to state the same basic relationship. When a position and velocity have the same sign, a particle must move away from the origin. And vice versa, when position and velocity have opposite signs, a particle must move towards the origin. And these are the basic movements that we have that you need to know about. Now, each of these statements of because are important when we answer things. So it's going to be important that you remember all of these reasonings. Because what you'll be asked is the particle moving towards or away at a specific time or moment? And you need to know what the position is, what the velocity is, and what the acceleration is at that moment. Once you know that, you can then say whether a particle is moving towards or away from the origin based upon this relationship between velocity and position. You will be able to identify whether speed is increasing or decreasing based upon the relationship between the acceleration and the velocity. Whether a particle is moving left or right is based upon a positive or negative velocity, or whether it's at rest when the velocity is equal to zero. Please remember that when we are talking about moving towards or away, moving right or left, we must have a situation where the object is at least moving. So when you are talking about intervals of increasing and decreasing, be aware that our sentence frames that we're going to get will involve brackets and parentheses. We'll be talking about that later as we start looking at sentence frames. Suffice it to say that when we are talking about the direction that a particle is moving, we do not include the endpoints where the particle is at rest. Okay? However, when we are talking about concavity, concavity also does not include endpoints. Okay? So there is no concavity when an acceleration is equal to zero. Okay, keep that in mind. And that's what I have for you for our review. Thank you very much. Be well, be safe, and I hope that this has helped you. And thank you very much, Horn.